We introduce here the Internet Control Message Protocol, or ICMP, and the function of ICMP as a protocol designed to support the smooth operation of IP. So ICMP is a protocol that works alongside IP as a form of messaging protocol in order to compensate for the limited reliability of IP. The implementation of IP is required to be understood to familiarize with the behavior of numerous operations and applications that rely heavily on ICMP, in order to support the underlying messaging based on which further processes are often performed. This section takes a look at the Internet Control Message Protocol, or ICMP, and the function and behavior of ICMP in support of IP. ICMP is a protocol that works alongside IP as a form of messaging protocol in order to compensate for the limited reliability of IP. The implementation of ICMP is required to be understood to familiarize with the behavior of numerous operations and applications that rely heavily on ICMP, in order to support underlying messaging based on which further processes are often performed. So upon completion of this section, it is generally expected that trainees will be able to describe some of the processes to which ICMP is applied, identify the common type and code values used in ICMP, and explain the function of ICMP in the ping and traceroute applications. ICMP in its simplest form can be understood to be a messenger protocol that is used to carry notifications necessary for ensuring the smooth operation of IP. These ICMP messages may be created by a source host, to which a reply is given by a gateway or end station as demonstrated here, or generated within the network in response to an event and redirected to the source. The notifications supported by ICMP include support for routing, the performing of diagnostic checks, and supplying error messages in the event of various IP-based problems. We give a number of examples here to demonstrate some of the typical uses for ICMP, beginning with a look at how it is used to support certain routing operations. The example here shows an event in which host A, that is part of network 10.0.0.0, wishes to forward traffic to a destination, which in this case is server A. Since server A exists in another network, host A must forward the packet to the default IP gateway, which in this case is the gateway with the address of 10.0.0.100. The gateway will then need to determine the network to which the packet must be forwarded, however finds that the best path is via another gateway, which is connected to the same 10.0.0.0 network. The default gateway for host A in response will generate a form of ICMP message known as an ICMP redirect. This message is used to notify host A that traffic intended for the network 20.0.0.0 should be redirected to the gateway of 10.0.0.200. The original IP packet sent by host A to the default gateway is forwarded by the default gateway to gateway 10.0.0.200 for the intended destination of server A. Ultimately, through this ICMP message, packets are rerouted to an alternate gateway for optimal packet forwarding. In this example, we demonstrate how ICMP messages generated by the source can be used to gather information for diagnosis of various problems and the current status of the network operations. A set of two ICMP messages, referred to as an echo request and the response message, or echo reply, are used to collect information about the state of the network. In the most basic form, the echo will determine connectivity between the source that generates the echo and the intended destination that is referenced in the destination IP address field of the IP header. If an echo reply is received, connectivity between the 2 points is verified. Additionally, though, various diagnostic information may be carried as part of the ICMP process and will rely on the IP options field of the IP header in order to support transportation of this diagnostic information, such as timestamps for the round-trip duration between the source and the destination. The reliance on the IP header further demonstrates the level of association that exists between ICMP and IP. The same echo process that is used for diagnostics may also apply to events where the intended destination is unable to be reached due to a number of possible reasons. However, for the main part, this may be down to the intended host on the network being unreachable, or the network itself being unreachable. The example demonstrates a scenario involving the transmission of data to a location in a remote network represented by server A. A gateway along the path is aware of the network to which the data is intended, on which server A resides, but discovers that the path is currently unavailable. Since the packet cannot be delivered, the gateway has no choice but to discard the packet and is obliged to then notify the source of the action taken. This notification relies on another form of ICMP message that is understood as a destination unreachable message. We show here how an ICMP message is carried as part of a frame. We should notice that there is no specific upper layer data, since this message is only intended for processes that operate at the network layer. But ICMP messages may be used by applications to generate system notifications. Common examples of such applications include ping and traceroute, and we shall detail later how these applications work with ICMP. Looking forward at the format of the ICMP header, we should take note of the type and code fields. These two fields play an important role in defining the type of message being generated, as well as the specific form of each message, and we should reflect on this in more detail in the next slide. A parameter field is used to carry certain supporting information such as sequence numbers, which shall be demonstrated when we take a look at the ping application. Finally, the ICMP packet may also carry additional information. We can give an example of this based on the ICMP redirect process, for which a response by the default gateway was sent to host A. During this response, additional information is also carried in the ICMP redirect message in the form of the IP address of the gateway, the IP header, and the first 8 bytes of the original datagram, or packet's data. This is done so to allow the host to match the ICMP message to the relevant process, which in this case involved the forwarding of data to server A. Coming back to the initial fields within the ICMP header, we can begin to further reference how each message type is defined. The table given represents an example of the common forms of ICMP message types, but does not provide a complete reference. We can take the destination unreachable ICMP message type that is determined by the type value of 3. We should notice that there are multiple forms of destination unreachable message, each of which is distinguished using the code field. Some of the other common forms of ICMP messages that have been introduced include the echo messages, which are made up of an echo request and an echo reply. It should be made very clear that this is not a single echo message that is sent or returned, but that the request defined with a type value of 8 is received often by the gateway and processed before being discarded, and a new ICMP message is generated by the gateway in the form of an echo reply with a type value of 0 that is sent to the original sender. We now introduce some of the typical applications that strongly depend on ICMP as the underlying mechanism. The ping application is found within a multitude of systems, from the operating systems of end stations to routers and other network layer supporting devices. Ping functions by sending out a fixed number of ICMP echo request messages, to which it is expected that echo replies be returned to the source address as referenced within the ICMP header. We demonstrate here how ICMP is used within a router as part of the ping application. We also demonstrate or detail some of the various parameters that are used to support the operation of ping. The ping command followed by the -a parameter will allow a source address to be specified. If no address is specified, the IP address of the outbound interface of a device will be used as the source address. The number of ICMP messages generated by the ping application by default may vary depending on the platform being used. However, within Huawei products that support ping, 5 ICMP messages are generated at one time. It is possible using the -c parameter to change this parameter to generate a larger or smaller number of echo request messages each time the ping command is executed. At times, it is possible an echo reply is successful. However, if the duration in which the reply is returned happens to exceed the default timeout duration, the ping application may specify that the request is timed out before the response was given. In such cases, it is possible to increase the timeout period using the -t parameter to ensure that the ping application waits for a longer period, set in milliseconds, before it decides to give up on ever receiving an echo reply from the destination. We can go ahead and demonstrate the result of generating ICMP echo requests through the ping application, and based on this diagram shown here, we wish to generate a request from RTA to the destination of RTB that has the address of 10.0.0.2. As a result of the ping command generated in the previous slide, we demonstrate here the response, in which 5 ICMP echo request messages have been generated, to which 5 ICMP echo reply messages have been returned. In this case, all requests have been successful, and we see additional information regarding the results. This information includes the number of bytes transmitted, the TTL value, as well as the transmission time taken from the IP header. The sequence number here represents the typical additional information that is carried as part of the ICMP message during transmission, and in this case is used to differentiate the various ICMP echo messages that were originally sent. Traceroute is another common application that employs ICMP echo messages to provide information, but in this case it is used to trace the path that is taken by data from the source to the destination, specified by the destination IP address that is referenced in the IP header. In this case, the TTL value is also used to limit the range of the ICMP message to one single hop initially, which is incrementally increased. Once the TTL reaches 0, an ICMP message will be returned to the source. That is used to determine the path and gauge the duration of transmission. Typically, 3 ICMP messages will be sent for each hop before the TTL value is incremented. The TTL value by default will begin with a value of 1. However, the -f parameter can be used to alter this as necessary. The range of the trace route can also be limited using the -m parameter if a shorter trace is required. Again, we can demonstrate here the use of the traceroute application based on the diagram shown, in which the path between host A and host B is determined, where multiple paths may exist. We can understand that host B has the destination address of 30.0.0.2. We see here the typical results generated by a traceroute operation. As the TTL value expires, the results are returned to the source and are displayed based on the hop that was reached, as well as the round trip time that it took on 3 separate occasions. Through such results, the end station host is able to determine the path that is taken through the network, as well as a clear indication that such a path exists and the transmission duration for this path. The traceroute application is a valuable tool for troubleshooting when a destination becomes unreachable. It not only will determine that the destination is unreachable, but can pinpoint the hop at which the connectivity is lost. If there is a problem with the path, such as in the case of routing loops, traceroute can be used to determine such issues. In summary for this ICMP section then, we ask a couple of questions here. The first asks, which 2 ICMP message types are used as part of a successful ping? Well, the echo request message defined with a type value of 8 will be used to generate the ICMP message that is sent to the destination. A separate ICMP message with a type field of 0 represents the message that is returned. In the event that the TTL value of the IP header of a datagram or packet reaches 0, what action will be taken by the receiving gateway? Well, if a gateway device receives a packet, it must firstly decrement the value of the TTL field before proceeding to forward the packet. If the received packet has a TTL value of 1, the gateway device will decrement this value, resulting in a TTL value of 0 prior to forwarding, which means that the packet shall not be forwarded, and instead the gateway will proceed to discard it and return an ICMP message to the source in order to notify that the datagram or packet failed to reach its intended destination. The form of ICMP message returned in this case would be of a type value of 11 with a code value of 0.